All right, guys, so this is going to be your homework video, and also I'm going to put this as a PowerPoint for you to look at and use the information one step at a time. So you have this video for explanation, and you also have the PowerPoint, as well as the PowerPoint for the first part of motion that we looked at. So, and if you also need a playback of the video of the lesson for the first lesson for motion, also please email me. I'm not going to provide that, but only by email. Okay, so homework is for this video is to go through all of the slides to modify your CityMap vision. All right, so it's time to ask nature now. And you see, I mean, this, if you just spend a minute looking at the shapes over here and how nature is distributing, the shapes, let's say, and the colors, and how there are patterns and how things are going intertwining. So, probably that would be an inspiration as well. Just, you could pause this for a second and really focus and see what's going on here, and maybe that could help inspire you a little bit. So, these are some shapes that that we find in nature, and they've been mimicked so many times now in technology and in building and in engineering and in just ways of doing life. And the reason why they've been mimicked is because nature runs on low energy. Nature is very efficient in terms of its space, and so basically we want to mimic nature in order to use space efficiently, in order to provide for everyone, in order to maintain community and social equity at the same time, and also maintain a healthy lifestyle. So these shapes and patterns could take you somewhere in your design. You could distribute your resources on your map, following and mimicking these different geometries that you see in front of you. So biomimicry is emulating nature's design and using it for our own benefit. The first way of mimicking nature and translating it into design context is by looking at the natural form, the geometry, the patterns, and the numbers, just like we saw in the previous slide. The second is the natural process, the structure of it, the building, the construction, the type of material, and the anatomy. Level 3 is the natural ecosystems, how it contributes to social responsibility, the interior environmental quality, and life cycle analysis. We're gonna, for life cycle analysis, like we're not producing anyways, then we're gonna look at this one as we go through the slides. So natural forms, it's known that the natural forms in nature, they follow mathematical patterns. One of them is the Fibonacci sequence that you see in front of you over here. So if you choose to distribute your map shape to follow a certain natural form, then here's one example. Here, this is the structure of the butterfly, however, the wing of the butterfly, which is providing also with camouflage at the same time. So it's doing more than one thing, and it's doing insulation and concealment. So it's so if we zoom in, we end up having this structure that ended up giving us this color and camouflage. Okay, so structure and shape is always the first thing we look at. Here's another structure over here. It's good for making the water roll off the surface. So maybe like if I want to catch the water, I want the water trickle down. So I'll use surfaces that are bumpy, surfaces that attract water, surfaces that repel water. Just showing you some shapes over here. I'm not asking you at this point. This will come later, but I like to just open some doors in your head. Now, this is and basically the natural process over here to continue to look at the structure and the construction and the type of material and anatomy. Basically, these are more shapes that we can look at, and there are reasons why they are shaped like this. This reduces the stress. It distributes the stress. It doesn't keep it in one place. And so basically, when we're talking about urban design, we're talking about, I don't want to put stress on one area. When I distribute my resources or my elements or my housing, I don't want to put everything in one area, like many of you mentioned. Like, you don't want to keep the housings only concentrated in one place, you want to distribute them. So here's an example. Then we have the level 3 is the benefits that it's going to bring to the society and the health and the environment. So the ecology of things. So there's something we call ergonomics. Ergonomics is just a word that makes you feel, it's how does, it means how does a place make you feel? You know, some places make you feel very comfortable, and some places, no matter what you do, they always don't make you feel good. So that's why some of you who picked concentric shapes, we like them because the flow of energy will create good ergonomics. So how will your city tackle the following? I mean, the resources, the material, like the food and the energy and the products, how are they going to be distributed in your city? The water as well. How is your city not going to be polluted? How is the human health being looked after? I mean, it doesn't have to be only hospitals, but also like activities that are going to keep the people also healthy, and social equity. And many of you mentioned many areas related to that in your plans. So, for example, when we say when we talk about materials and how you want things to flow in your city, you want a kind of city that doesn't produce waste, a kind of city that works on something called cradle to cradle, meaning there's a circular loop. It's moving in a circle, so that your materials, they stay in and you don't have to reuse more. You don't have to dump things. You don't have to dump it in the landfill. You're reusing things, you're repurposing things, you're upcycling. These two mean reusing. Okay, so you're not throwing things away. You're finding ways that the city is not producing waste. The city does not run on disposables, let's say, for example. If you can add that, I just like to give this idea. This is, for example, one group mentioned a recycling center, for example, or a repurposing center, remaking center. Now, your task is to follow, is to work on biomimicry now. Use nature to inspire you in how you are going to locate your elements. Number one, I need you to go to the first inspiration that's given to you. You click on this website, and you need to type in the word shapes. Now, when you type that in, you're going to see a list of examples on your right-hand side. Click on those that you find that you like for inspiration. The second one I need you to do is also do the same thing, but now look up the term veins and click on examples that you find that you like for your own inspiration. The last one is for distribution of resources. You want to click on this link and also click for examples that will inspire you. So by that time, you're looking at as much as examples as you can, that research part, your observation also. That's the first part that we do. We try to observe and from after researching. You're going to then, number 4, select the shape that you want to mimic and copy for your map. So copy and paste, you want to then get some graph paper, copy and paste the graph paper onto the program called Paint on your laptop. And then this will allow you to be able to draw. So you can draw, number 6, you can draw the shapes you want on the graph paper on Paint. So you can copy and paste the shape of a vein, for example, veins in the leaf. You can paste them there. You need to make 50% of the land for a human-built environment and the other 50% for the natural part, okay? So you want to leave buildings and all of that for the human beings, 50%, and the other part needs to be left for nature. Why? Because they have a job, because they control the climate, because they need to be there, because they are essential for us. And add to your elements based on the feedback that I gave you in class. What to add more? I need you to consider the human health, I need you to consider social equity, the ecology, catching water, generating electricity. You've already had that. Adding food forests and gardens between homes, farms, water flows, etc. Okay, that's going to be some, that's going to help you for point 7 as well. Then you need to add a scale. How much does 1 centimeter on your graph paper represent in real life? How many kilometers, let's say, or meters? And optional, if you would like to add the area of 1 centimeter squared, how much would that represent in real life? Okay, so like the area for housing, how much should that be? Okay, here are some examples. So this is graph paper. So you can draw, you can add numbers, and then next to the number, you can put a key if you like. Here's a color-coded one, but here we have hexagonal shapes, and then each color could have a code in the key. Here's another shape that's been drawn on graph paper, and then we can add also codes over here with their numbers. So this is going by numbers. This one is drawing, and now we need to add more drawing and numbers to it, but I'm just showing you how it can work out nicely on graph paper. Also, you can draw on graph paper if you want. This is just, a vision that you might have had before I gave you the graph paper, but now with graph paper, how are you gonna just put it there, okay? Here's another one without graph paper, but I'm just showing you how you can, start now using drawings if you like symbols, because many of you use symbols, so that also can work. But I need you to use small symbols, not big ones. And these obviously need to go on graph paper. Now here's a hexagonal shape, probably, because this is a very efficient way of distributing space efficiency. So if you're looking for best space efficiency, you go for this. Here's another one with numbers, if you like. Here's another one with more numbers. And here's, how you could be drawing things, if you like. If you want to draw, color, put your labels, put your symbols, put your numbers, whatever you want, just make a key with it. So here's a graph paper figure that you could copy and paste if you like on Paint, if you don't have it, or if you want to print it out. But please don't come in close contact together because, of the COVID-19 situation. So let's try to work remotely. What's next? What's next is we're going to now start looking at coordinates and coordinates for your motion now. You're going to have to be working on motion. So the rest of what we took in motion, basically connecting the dots. So technically, we looked at a new vocabulary as coordinate system, origin. We're going to be looking at position, distance, magnitude, vector, scalar, time interval, displacement, and resultant. And I need you to pause the video and actually write these down, okay? And as we go, we're going to learn the meanings of these. So many quantities, we're going to write down now the title, vectors and scalars. Many quantities in physics have both size, and they're also called and are called they have a magnitude. If they have a quantity has size and direction, it is called a vector. So you represent vectors with an arrow, and for example, the length of it will represent the size of this quantity for with an arrow. Scalar quantity only has the magnitude again. So for example, the distance. A vector quantity has a size and direction. For example, displacement, meaning I'm giving a direction in which way I am going. So -6 kilometers, minus means I'm going due west. Okay, so just to let you know that your map now is going to be used again, and you're going to make your own coordinate system on it for next lesson. So, and then after we go through some explanation, and therefore your map is very important to be ready by next class. Thank you so much.